Now let me introduce the second section. There are 6 questions in it. There may be more than one answer. What about the first one in this? For diatomic molecule, the correct statement about the molecular orbital formed by the overlap of two 2p set atomic orbital. First statement, sigma orbital has a total of 2 nodal planes. If you are assuming Z as molecular axis, clearly you know that sigma 2pz and sigma star 2pz may be resulted. How is sigma bonding molecular orbital produced? If you are considering atomic orbital wave function in this way, there will be constructive interference that may result a bonding molecular orbital. And in that bonding molecular orbital, no doubt between the nucleus there is no nodal plane. Between the nucleus you cannot realize a nodal plane, but you can see there are 2 nodal planes situated, isn't it? They simply say there are 2 nodal planes, so you can take that statement as correct. What about the B option? Sigma star. How is sigma star orbital produced? If you are considering atomic orbital wave function in this way, there will be destructive interference that will result antibonding molecular orbital. And in this antibonding molecular orbital, you can see here it will be negative, here is positive, but here again what? Here is negative and here it is positive. As a result of that, if you are considering bonding and antibonding, in the case of bonding I told you there may be 2 nodal plane, but there is no nodal plane between the nuclei. But what about sigma star? In this case, the bond nucleus is here, isn't it? The bonded atom, the nucleus can be marked here, and no doubt there is a nodal plane in it. But they say that nodal plane is in XZ plane is absolutely wrong. You know, this lies along the Z axis. Since it lies along the Z axis, you cannot say XZ plane is a nodal plane, because in that plane there is electron cloud. So nodal plane is there. That nodal plane should be in XY plane. If you are taking Z axis as this, XY plane should be a nodal plane. So clearly this statement is wrong. What about the third statement? Pi orbital. How is this pi orbital produced? If you are assuming x-axis or y-axis as molecular axis, Z lies perpendicular to it. In that case, you can say there is formation of pi molecular and antibonding molecular orbital. So pi orbital produced, pi bonding molecular orbital is produced, has one node in the plane which is perpendicular to the molecular axis. Now let me consider the formation of pi bonding molecular orbital. You can see pi bonding molecular orbital is produced in this way. And here you can realize a nodal plane, but that nodal plane lies like this. That nodal plane, no doubt, between XZ plane, which lies in XY plane. Am I right? Because this plane should be what? XY plane then. So clearly, they say it is perpendicular to the molecular axis is wrong. This is along the molecular axis. Clear? I will repeat. If X is considered as a molecular axis, you can get pi bonding molecular orbital based on the combination of 2pz. And the pi bonding molecular orbital seems to be like this. And the nodal plane like this. That nodal plane should necessarily be in XY plane. Am I right? But they say that is perpendicular to the molecular axis. The molecular axis, no doubt it is X. The nodal plane is not perpendicular to it. Instead, the nodal plane is parallel to it. So, this statement is wrong. Pi star orbital has one node in XY plane containing the molecular axis. How is pi star orbital produced? You know, the destructive interference, you can write either like this, or you can even put negative sign in between them. That is plus minus here and again plus minus here. As a result, you will get what? antibonding molecular orbital. As a result of this antibonding molecular orbital formation, what about the wave function sign? Here it is positive, here is negative, and minus of plus you can write it as minus, and minus of minus you can put it as plus. So here it is minus and plus. And between the nuclei you can realize a nodal plane, and there is one more nodal plane which is along the nucleus. Am I right? There are two nodal plane here, one like this and the other like this. Between the nucleus there is one nodal plane. Pi star orbital has one node in XY plane, no doubt. In XY plane there is one node because you are taking pz atomic orbitals. So XY plane is a nodal plane. That statement given is also correct. So here A and D are correct statements. Now let me go to the next question. The correct option related to the adsorption process is chemisorption results in unimolecular layer. No doubt, in chemisorption, the interaction is like a covalent bond or ionic interaction. That means it is monolayered, whereas physical adsorption is multi-layered, you know. What about the second one? Enthalpy change during physisorption is wrong. You know that it is around 20 to 40 kilojoule per mole. Chemisorption is endothermic is wrong. Chemisorption is exothermic. Adsorption should necessarily be exothermic because during adsorption, delta S is negative. In order to occur a process, delta G value should be negative. To get delta G value negative, delta H should be large negative. So the adsorption process should necessarily be exothermic. Lowering the temperature favors physical adsorption is correct. Physical adsorption favored by low temperature, but chemisorption require an activation energy, you know. So here also A and D are the correct options. Now let me go to the next question. The electrochemical extraction of aluminium from bauxite ore involves reaction of Al2O3 with coke at a temperature greater than 2500 degrees C is wrong. You know that aluminium metal can be obtained only through electrolytic reduction because aluminium itself is a very powerful reducing agent. All active metals that you have studied in high school classes, an activity series, POSO, Kama, ALSI, INI like this. So all the metals and metals in between them can be obtained only through electrolytic reduction. The second statement, the neutralization of aluminate solution by passing CO2 gas to precipitate hydrated alumina. That statement is correct. Even though hydrated alumina is strictly, it may not be Al2O3 3H2O. Anyway, it can be Al2O3 XH2O. You can write it in that way. Anyway, that statement can be considered as correct. You know that bauxite ore is dissolved in hot concentrated NaOH. The impurities like silica and our ore Al2O3 also get dissolved. But other impurities, impurities of iron is not dissolved and that can be filtered off. Now the solution contains sodium silicate and also sodium aluminate. To precipitate sodium aluminate, what we are doing? We are bubbling carbon dioxide through that. So that statement is correct. Dissolution of Al2O3 in hot aqueous NaOH, that is wrong. We are not dissolving Al2O3 in NaOH, but we are dissolving bauxite. We are dissolving bauxite ore in hot concentrated NaOH to remove the impurities. And I told you earlier, and then the sodium aluminate is precipitated by bubbling carbon dioxide through that. So the C option can be considered as wrong. We will never dissolve alumina obtained to NaOH. Instead, Al2O3 is dissolved in molten cryolite. Al2O3 is melted and it is dissolved in molten cryolite and subjected to electrolysis. What about the D option? Electrolysis of Al2O3 mixed with cryolite to give aluminium and carbon dioxide. That you know, that is correct statement. Al3 plus will migrate to cathode and you will get aluminium at cathode. Meanwhile, oxide ion migrate to anode and that will consume the carbon and carbon get transformed into CO and CO2. CO2 gas along with the CO is produced during electrolysis. So here you can take B and D are correct statements. Now let me go to the next question. Treatment of galena with nitric acid produces the gas. All of you know PBS when treated with nitric acid, the gas produced is nitric oxide. Since it is an odd electron species, it should necessarily be paramagnetic. And again, you know, it is a neutral oxide. NO, N2O, CO, these are typical three neutral oxides, you know. It possesses bent geometry is absurd because there is only two atoms and no doubt it is colorless. So you can say A and D can be correct options. Now let me go to the next question. Consider the reaction sequence given below. First, propanoic acid is taken. It is subjected to HVZ reaction. As a result, what can be P? P, no doubt, 2-bromo-propanoic acid. 2-bromo-propanoic acid, then subjected to what? Potassium thalamide. So, you are expecting Gabriel thalamide reactions here. So, CH3, CH, COOH here, and here you are getting what? You are getting N-alkyl thalamide in this way. Am I right? So, N-alkyl thalamide is obtained in this case. This is subjected to hydrolysis. So, what is expected? On hydrolysis, you can expect the formation of primary amino group. So, you are getting alanine. Alanine, you know, is the second alpha amino acid. The first one being glycine, the second one is alanine. So, the Q obtained here is alanine. Clear? Now, let me read the options. P can be reduced to primary alcohol using sodium borohydride. It's wrong. You know, carboxylic acid group can be reduced to alcoholic group by lithium aluminum hydride or by treating it with diborane. But sodium borohydride cannot reduce carboxylic acid to alcoholic group. So that statement given is wrong. What about the second one? Treating P with a concentrated ammonium hydroxide solution followed by acidification of gives Q. We know the Q product is alanine. Let me go through the path indicated in option B. Treating P with the ammonia solution, no doubt. You know that when ammonia is treated with alpha halo acid, you will get alpha amino acids. So, concentrated ammonium hydroxide means ammonia solution. You can replace bromine with NH2. Along with no doubt, COOH becomes COONH4. Followed by acidification, you will get back COOH group. So, that statement is also correct. The Q can be obtained through that path also. What about the third option? Treating Q with a solution of NaNO2 and aqueous HCl liberates N2 gas. No doubt. If there is a primary amino group, when primary amino group is treated with nitrous acid, you know that we will get alcohol with the liberation of nitrogen gas. They say D is more acidic than propanoic acid. P is more acidic than propanoic acid. Clear? Because bromine possesses minus I effect. All alpha halo acid possess greater acidic strength than the parent acid. So, P is more acidic than propanoic acid is also correct. So, there are B, C, D options are correct. Now, let me go to the next question. Consider the following reaction sequence. First one is given as para-nitrotoluene. This is subjected to a reagent P so that you are getting Q as the product. Then it is subjected to another reagent R so that you are getting S as the product. S is treated with another reagent U, you will get benzoic acid. What is the first option given? First option say P can be catalytic reduction. See, if P is catalytic reduction, what is expected? If P is catalytic reduction, the expected product Q can be what? Q can be para-toluene. When para-toluene is subjected to R, what is R given? Diazotization. Then what can be S? S can be diazonium salt. This can be diazonium salt. So in order to get benzoic acid, what can you do? You can remove this N2Cl group. In order to remove N2Cl group, you can take either H3PO2 or you can take ethyl alcohol. So H3PO2 will remove N2Cl group, and meanwhile alkaline KMnO4 solution will produce what? Benzoic acid group. CH3 can be oxidized to benzoic acid. So the first sequence given is correct. What about the second sequence? Second sequence say reduction and diazodization. So that part is common. Then they say S can be this. What about S? No doubt. S obtained should be that. So that part is also correct. Then S is this that we have already seen. Then T can be this. What is T? T is obtained by hydrolysis. No doubt, when N2Cl group is hydrolyzed, you will get what? You will get OH group. So clearly that part is also correct. Now, what about U? U can be alcohol and treating with the KMnO4 solution. As a result, you will get benzoic acid. We have already seen that. What about D option? D option Q is para-nitrobenzoic acid. Never. By reduction, you cannot convert CH3 into COOH. So that option is clearly wrong. So there are three correct options A, B and C. Now you want to consider section 3. This is match the following type questions. Let me consider the first question. Match the rate expression in list 1 for the decomposition of X with the corresponding profiles provided in list 2. Xs and K are constant having appropriate units. The first, they say rate equal to K into concentration of X divided by Xs plus concentration of X under all possible initial concentration of X. Suppose X is very small. Concentration of X is very small compared to saturated concentration. We can neglect concentration of X in the denominator. Then you can say rate equal to K into concentration of X divided by Xs. K by Xs is a constant. Therefore, you can say rate is directly proportional to initial concentration. But if concentration of X is much higher than saturated concentration, what will be the case? That means in that case, Xs is much less than concentration of X. And here you can say in the denominator, you can approximate Xs plus X as X itself. So R equal to K into concentration of X divided by concentration of X, or practically you can say rate is a constant. It is independent of concentration. How can you represent that graph? You can say that graphic representation should be like this. That means at lower concentration, the rate is directly proportional. That means the graph is almost straight line. But beyond saturated concentration, you can get a straight line which is independent of the concentration of X. So for first one, you can say this graph is highly conveyed. And again, we are coming to the second one. In the case of second one, they say rate equal to K into concentration of X divided by Xs plus concentration of X, where initial concentrations of X are much less than saturated concentration. Initial concentration of X is much less. That means what? Xs is much higher compared to concentration of X. And in this case, you can say the denominator is simply Xs only. Therefore, you can say R is equal to K into concentration of X divided by Xs. Because in the denominator, you can neglect X because it is much less than Xs. So you can say this is, we have already seen K by Xs is a constant. So we can say R is equal to K into concentration of X, or R proportional to concentration of X. It's a first order kinetics. For a first order kinetics, you know the half-life is independent of initial concentration. So the second one is conveyed in Q. And again, you know that since it is a first order kinetics, clearly you know that for a first order kinetics, ln R0 by R is equal to Kt, or you can say ln R0 minus ln R equal to KT, or you can say ln R equal to ln R0 minus KT. This is in the form y equal to mx plus c with a negative slope, and the slope will represent the k. So that's also conveyed in option T. So for first order kinetics, you can say what option T, and also you can represent option Q. Both represent for first order kinetics. Clear now? Now we are coming to the third condition. They say rate equal to K into concentration of X divided by saturated concentration plus X, where initial concentration of X are much higher than XS. That means XS much less compared to concentration of X. So the denominator can be taken as simply concentration of X. So that concentration of X can cancel, you can say rate is independent of concentration. That means it is a zero order kinetics. For a zero order kinetics, you know that the graph S will convey zero order kinetics, because for a zero order kinetics, R0 minus R is equal to KT. So the concentration X or R is equal to R0 minus KT. Here also the slope will be K. And again, you know, for a zero order kinetics, half-life is directly proportional to initial concentration. So the first graph also conveys for a zero order kinetics. And what about the fourth one? In the case of fourth one, kx square divided by xs plus x, but initial concentration of x is much higher than xs. In that case, you can say xs plus concentration of x is nothing but concentration of x itself, because xs is much less compared to concentration of x. And in that case again, you can say this is a first order kinetics, since R is proportional to concentration of x. So this is again a first order kinetics. We have already seen for a first order kinetics, the graph T and also graph Q is applicable. Am I right? Now let me go to the next question. List 1 contains compounds and list 2 contains the reactions. First, let us analyze the reactions given. In the first reaction, they say magnesium bicarbonate reacts with calcium hydroxide. What are the product expected? We know that magnesium hydroxide readily get precipitated along with calcium carbonate. Water is also produced. What about second one? Any peroxide when treated with dilute acid, you will get hydrogen peroxide. So barium peroxide reacts with sulfuric acid, you will get hydrogen peroxide and barium sulfate. What about third one? Calcium hydroxide with magnesium chloride. You will get a precipitate of magnesium hydroxide and also calcium chloride. What about S? Barium peroxide with HCl gives barium chloride along with hydrogen peroxide. Hydrogen peroxide, barium chlorides are the product. Calcium bicarbonate with calcium hydroxide. You will get a precipitate of calcium carbonate. Now we can see list 1. Hydrogen peroxide. Hydrogen peroxide is obtained from, you can see Q will give you hydrogen peroxide and S also will give you hydrogen peroxide. Magnesium hydroxide. Magnesium hydroxide obtained in P and magnesium hydroxide obtained in R. These two will give you magnesium hydroxide. Barium chloride. Barium chloride is produced only in S option. Calcium carbonate obtained from P and also from T. These two will give you calcium carbonate. You can find out the appropriate matching given below. Now let me go to the next question. List 1 contain metal species, list 2 contain their properties. List 1 contain coordination compound and list 2 indicates their properties. What about the first coordination compound, hexacyanidochromate 2? We know that chromium has an outer configuration 4s1 3d5 in the ground state. Chromium plus 2 means that is 3d4. So no doubt it is a d4 species. And again, cyanide being a strong ligand, all the 4 electron lies in T2G level. There is no electron in Eg. So T2G, it contains 4 electron is correct. And again, its root of 2 into 4, that means root of n into n plus 2, there are 2 unpaired electrons. Root 8 will be the magnetic moment, root 8 Bohr magnet n. So Q is not applicable for the first one. No doubt it is a low spin complex. Hence you can take R, and it is exists in plus 2 oxidation state, and also it possesses D4 species. What about the second one? Ruthenium. You know, ruthenium possesses an atomic number 44, that is just below to iron. Iron, you know, the configuration is 4s2 3d6. So the expected configuration of ruthenium is 5s2 4d6. But actually, ruthenium possesses the configuration 4d7 5s1. And the oxidation state of ruthenium in that complex is plus 4. Am I right? So it possesses plus 4 oxidation state is correct. And what about chlorine? For ruthenium, chlorine can also behave like a strong ligand. Therefore, you can say all the 4 electrons again lies in T2G level. So T2G4 is also applicable for that. So you can take T2G4 electron applicable there, and you can say it possesses D4 configuration, that also possible to it. D4 configuration is also possible, and its oxidation state is plus 4. All this, and again you can even say it is low spin complex. And what about the third one? Third one, they say chromium in plus 2 state, hexa aqua chromium 2. And again, chromium 4s1 3d5, you know. So 2 electron lost means 3d4. So chromium is also d4 configuration. The oxidation state of the metal is plus 2. Water being a weak ligand, there is no forced pairing in it. Therefore, the unpaired electron here is 4. All the 4 electrons in D found to be unpaired. So root of 4 into 6, root 24 Bohr magnet 10, that is 4.9. So 3 can be given with what? 3 can be given with Q, and also 3 can be given with the T. Now what about fourth one? Fourth one is iron exists in 2 plus state. Iron 4s2 3d6, 2 electron lost, so it is 3d6. Water being a weak ligand, you can see the d6 configuration in such a way that T2G level contain what? T2G level contain 4 and EG level contain 2. T2G4 is also correct. Here also you can say T2G4, and again Bohr magneton observed is 4.9. It's a high spin complex and the oxidation state is plus 2. And again the species is not D4, instead the species is D6. This is almost conveyed in option A. Now let me go to the next question. Match the compound in list 1 with the observations in list 2 and choose the correct option. What are the compounds given? Aniline, orthocresol, cysteine, caprolactam. Various experimental observations are also given. First, let me analyze these compounds. In aniline, you know, benzene ring attached with NH2. Orthocresol, you know, OH and CH3 group are ortho to each other. Cysteine, you know, in alpha amino acid, NH2 group attached to an alpha carbon, and again that alpha carbon contains CH2SH group. Then only cysteine is obtained. Caprolactam is a monomer of nylon 6. That structure is also familiar to all of us. And what are the experimental observations given? Sodium fusion extract of the compound boiling with ferrous sulfate followed by acidification of concentrated H2SO4 gives Prussian blue color. You know, in Prussian blue color formation, that is ferric ferrocyanide, is obtained only if the nitrogen is in it. The organic compound, first one contain nitrogen, third also contain nitrogen, fourth one also contain nitrogen. But the problem associated with the third one is nitrogen along with the sulfur is present. Hence, you can get blood red color during the first experiment. So here you can say aniline and also caprolactam can fit for P observation. What about Q? Sodium fusion extract of the compound on treatment with sodium nitroprusside. Sodium nitroprusside test is used for detecting the presence of sulfur. So third one can be given for Q. And what about the R? Addition of compound to a saturated sodium bicarbonate solution. You know that bicarbonate will produce brisk effervescence with carboxylic acid group. So you can say this can be applicable for R. Cysteine contains COOH group, hence bicarbonate addition will produce effervescence. What about the fourth one? The compound reacts with bromine water to give white precipitate. You know, aniline will get readily precipitated. Aniline on action with the bromine water, you will get 2,4,6 tribromoaniline. So first one can be given with the S also. Treating the compound with a neutral ferric chloride solution produces violet color. You know, the reagent neutral ferric chloride is used to detect the presence of phenolic group. If OH group is attached to the benzene ring, you will get violet coloration with ferric chloride solution. Among them, only the second compound contain, that is orthocresol contain OH group attached to the benzene ring. So we can say 2 is given with the T. These are the proper combination. So the possible answer here is option D.